Now we will see problem 3. A copper wire has a resistance of 30 ohms at 40 degrees centigrade. 30 ohms at 40 degrees centigrade, and this will be T1 and this will be R1, and calculate the resistance at 140 degrees centigrade. Here calculate its resistance at 140 degrees centigrade. Assume this as T2 temperature and final temperature, and you have to find out R2. Given temperature coefficient of resistance at 40 degrees centigrade is temperature coefficient is given 0.0036543. Here he has given small logic. Here it is said that coefficient of resistance at 40 degrees centigrade. Here 40 degrees centigrade is T1 degrees centigrade and nothing but alpha 1. Okay, we'll see here. So by using small diagram, we'll try to understand the concept. As I said, try to read the problem 2 to 3 times, if possible 4, and it will be clear. Nothing but you can understand the concept then. Okay, you have taken a copper wire, and at that the resistance R1 will be 30 ohms, and at T1 temperature equal to 40 degrees centigrade. 30 ohms at 40 degrees centigrade, and at T2, T1 will be the initial temperature and T2 will be the final temperature, where it is 140 degrees centigrade, and asked to find R2 value. And yet given temperature coefficient at 40 degrees centigrade, that is 40 degrees is nothing but T1 temperature value. T1, what is the T1 temperature value? Equal to 40 degrees centigrade. So temperature coefficient is also asked to find 40 degrees. What is 40 degrees? That is T1 equal to 40 degrees. Nothing but once T1 is there, then we have it is nothing but it is alpha 1 equal to 0.0036543 per degree centigrade. So by this small logic, we came to know that alpha 1 will be the T1 temperature is value is 40 degrees centigrade, then it is considered as therefore that is called alpha 1 value is this is 0.0036543 per degree centigrade is the alpha 1 value. Temperature coefficient is alpha 1. Okay, where alpha 1 is the temperature coefficient at T1 degree centigrade. Okay, at T1 degree centigrade, this alpha 1 value will be there, and it has given data from the above question clearly. After understanding that question, we can write, as I said, we can write down given data. R1 at 30 ohms at 40 degrees centigrade, T1 equal to 40 degrees centigrade, it is an initial temperature, and T2 is 140 degrees centigrade, it is final temperature. R2 equal to how much? At 140 degrees centigrade. So 140 degrees is nothing but T2. Then what will be the R2 value? Here he has given temperature coefficient at 40 degrees is 0.0036543. That is 40 degrees is nothing but T1 degree centigrade, as I said, where alpha 1 is the temperature coefficient at T1 degrees. Nothing but at T1 degrees, what will be alpha means alpha 1 itself. So by using the relation temperature resistance at any temperature, the same resist previous here we'll use total R2 resistance equal to R1 into 1 plus alpha 1 T2 minus T1. This equation, this R2 equal to R1 1 plus alpha 1 T2 minus T1 is also we have discussed in the previous topic, and submit the above values. Okay, this was discussed in the previous topic, relation between known resistance and unknown resistance in terms of temperature coefficient. In that topic we have discussed about this. Okay, this formula. Here after submitting the values, here R2 equal to 30 into 1 plus 0.0036543. Here T2 minus T1, temperature 2 is 140 minus T1 is 40, then 30 into 1 plus 0.003654 into 100, then your 2 decimals it will move to the right, but it will be 0.36543 plus 1 means 1.36543 into 30 equal to, you will get R2 value as 40.96 ohms. Okay, hope it is clearly understood. Thank you.